Welcome to our event. This event is brought to you by Datadog's Club, which is a community of people who love data. We have weekly events, and this is one of such events. If you want to find out more about the events we have, go to the description. There is a link. Click on this, and you'll see everything we have in our schedule. And if you haven't subscribed to our YouTube channel, now it's the best time to do this. Just go below the video, click on this subscribe button, and you'll get notified about all our videos. And finally, we have an amazing Slack community. Now, you're missing out if you're not there, so go below the video, click on this link, and you'll join our Slack community. During today's presentation, you can ask any question you want. There is a pinned link in the live chat, so click on this link, ask your question, and we will be covering these questions after the presentation. So that's all from me, and now the floor is yours, Tomek.
Thank you, Alexei. Thank you for the invitation. My name is Tomek Jamiński. I'm head of data science at OLX, and I think the company OLX rings a bell, I think, with many people here in this community. And today I would like to cover the topic of data monetization with machine learning. And I hope that by the end of this talk, you will be quite inspired and you will have quite some new ideas on what you can do with your data, at least based on the examples that I can show. Quickly introducing OLX, I think it doesn't need introducing, but in case you haven't seen this before, OLX Group is actually the biggest internet company that you've never heard of. We're present with more than 20 brands all over the world. And by all over the world, we mean globally and also in Europe, stretching from Portugal to Kazakhstan and Uzbekistan, so covering quite a wide range of emerging markets. And our presence gives us the possibility to serve 100 million customers every month. So it's quite a number. And these customers, they produce 1.5 billion of rows of data every single day. So that's a lot of data that we can play with. And what we do with that is we have learned ways to actually use machine learning to convert that raw data into value, to convert it into money. And I would like to show you today how we do it. So what you can expect from me to cover during the next 25 minutes or so is to talk about customer centricity, which seems to be a very popular buzzword, but I will explain exactly what it means in the context of machine learning. The essence of machine learning value creation. Then we'll cover some cross-functional ecosystems that allow us to implement those things in action. And I will also go through a couple of practical examples of data monetization. And that is the OLX VAS suggester. So OLX general classifieds VAS suggester. And then we will also deep dive into one of our real estate verticals, the Autodom, and the solution that we developed there, which is called Radar. I'll wrap it up with some key takeaways, and we'll of course leave some space for Q&A, because I'm sure there are a lot of curious minds out there. So let's go. Let's start with the customer centricity and what it's all about. It says
maybe just I'm not sure if everyone actually knows what OLX is doing. Maybe you can quickly show one of our websites so people get an idea.
Let's go there. That's a good idea. So let's go to OLX.pl. That's the Polish version of OLX, and yeah, accepting cookies. Let's translate that to a language that more people can understand. So OLX is basically a classified service where you can post items that you want to trade, be it new goods or used goods, but you can find here almost everything, from cars over to real estate, jobs, electronics, fashion. Let's look for a tractor. Tractors are
the most interesting thing, right?
Most interesting thing for some people. But you can see some vintage, vintage pieces, but also some nice pieces. I was always interested into those little ones, the lawnmowers, like the ones that look like toys. But yeah, this is more or less classified, right? So we have a lot of people who post their content, and then even more people who come to look for the things they want to find. That's what OLX is in essence. And it's interesting that you can either contact the user directly here, because you wouldn't buy a tractor through one click
delivery,
and it's rather not possible. But in other categories like books or things which can be shipped through for package, you can order that with a click as well and pay for that thing and get it delivered to your door. So it's a combination of both. It blends the world of classifieds and e-commerce together into one. So I hope that answers the thing.
Yeah, that does.
Yes. Okay. So what about customer centricity? What does it mean for us? And here, if we talk about the customers, I will just focus on the selling side, right? So if I mean customer, I will mean the seller. So our customers, they want to sell. They come here, they post things, and they want others to buy it, right? And those customers, they want to see the benefits of machine learning, and they don't want to listen about model features. That's the key differentiation about if we talk about customer centricity. So what that means is, if we want to use machine learning to convince our customers to use something, we have to learn to use the language of benefits. We have to sell it to them, right? If you watched Wolf of Wall Street, there's the scene where he asked those guys to sell him this pen. So it's a similar situation for us. We have neural networks, we have different models, we have gradient boosted trees, but it's not something that we can give to the customer and say, hey, we have a great neural network. Why don't you try that to sell your stuff? Because they will not understand it. What they understand, though, is that we have a new solution that will shorten your sell time and you will be able to sell faster. Or we can say you will save 2 hours per day using that solution and you will sell more. And this is something customers understand because it's the language of benefits. It addresses their needs. So data models alone will not solve any customer problem. That's also one true fact, because you might have the best possible model in the world, but unless it's applied in the right way and bought into by the customer, it will just be a model. But what solves problems is insights that these models can generate. So what is an insight? An insight is a piece of information that puts new light onto things that we sometimes know. Sometimes it's something obvious, but imagine you're a customer with hundreds of items, right? What would be the information that you would need? For instance, you would need the information which items to promote in order to sell faster. So that's what insights do. They provide you with non-obvious information that makes you act on something. And the thing with the insight is that the less obvious the insight is, the higher the information value it has. I'm not sure if you are familiar with Shannon's information theory and the whole concept of information entropy, but I mean, since it's Data Talks Club, I think you are familiar with that. But the thing is that imagine a sine wave, right? A sine wave doesn't carry any information because it's absolutely predictable. If you know the amplitude, if you know the period of that, you can predict any point in time precisely. But a small distortion along the way, right? A peak somewhere on a timeline, that carries a lot of information because it can mean something, right? There's some information in code that you don't expect that thing to happen. So this is the value of information, unless it's not noise, because we don't want noise in there. But it's the same thing with people. If we want to create value, we have to do that with information value. We have to optimize what we do to carry a lot of information value for that customer. So let's play around with a little bit of an analogy, and now use your imagination. So if data is the oil, then insights, so the information that we carry, are like diamonds. So what we want to do here is we want to take the raw data, which could be an analogy of crude oil, and we want to transform that into something valuable for the customer. And this is what we do. So raw data has low information value because it's just the commodity. It's the thing that we need to transform into something meaningful before it can reach the customer and before it can be seen as something valuable. So the first step is data engineering. So it's kind of like the refinery for information. We take the raw data, we process it, we stack things together, we put them in order, and that's how we get information from this raw data. And information could be the analogy to fuel. So it's already something. It has a higher value than raw data, but still this is not enough, because information in that context would be, you have, let's say, 100 tractors on your listing, and then for each and every tractor, we provide you statistics about how well it's doing, how many people have seen it, etc. It has a certain value, but it's sometimes not enough to trigger a particular user action. It's not enough to make efficient decisions. What if you have 10,000 tractors in your offer, right? Then you would have to go manually through all that information. I mean, you can do that, but it's still not the insight that you need to take action. So we need another step. And here's where machine learning comes in, because if we had a lot of information, we can build models to process that, learn from it, and deliver actionable insights to the customer using machine learning, which are the analogy of diamonds. And there we have already transformed something raw into something that has a lot of information value. So an actionable insight is, for instance, the information on which of these hundreds of or 10,000s of tractors have the highest probability of selling within the shortest period of time. Because that's something you could perhaps figure out yourself if you had the right tools. But since you're a salesman, your job is to sell tractors, right? Your job is not to run analytics on these tractors. So we provide something for the customer that they would usually not be able to do on their own, and that has value. And this is not obvious for them. So how do we put that into practice? Because this is all nice, right? We can draw anything we want, any schematic we want, but in order to make it work, we need to make sure that we have the right organization behind this. As you might think, data science doesn't work alone. It is needed and it is necessary that we collaborate with product research and analytics. And what do all these other functions do? Because different organizations have different functions in it, and I'm going to try to explain briefly what each of them does. Research, I think it's very easy to explain. This is the function that is able to run UX research with customers, collect information in a quantitative or a qualitative way. So, for instance, explain to everybody else inside the organization how customers look for things or how customers post items on OLX, and explain what is the process, and also quantify how many people use which type of approach in a given way. And that is very informative because that is also the source of key problems that we need to solve for customers. Then analytics is able to analyze everything that happens on the platform in a quantitative way. And in product, those are the people who actually decide about the design of features or how we are going to serve all this information and all the things that we develop to the customers. And then we also come into that combination to work collaboratively with everyone to make sure that, first of all, we inform ourselves based on research, analytics, and what product goals are. And we also return back solutions that respond to particular customer problems. And that's the essential thing here. We need to be aware of the particular customer problem before we solve it. So it's not about fantasizing what could be the next big thing, but rather sitting together with everyone and understanding what is the problem out there that we need to solve. And if it's a problem, that should be solved with data science. Now, so that's regarding collaboration, but it's also important to mention how you should position yourself in the organization to make it all work. And this will take a bit more time. And please bear with me because you see here 4 stages of development of a data function. You can see it this applies both for data analytics, but you can see it also for data in general. Now, at OLX, we want to make sure that data is a strategic partner or a source of competitive advantage. And I'm not saying that because we are bragging. I'm saying that because it has a very practical meaning. Namely, if we would be at the newcomer stage, and we would be a fully reactive function, and mostly tactical, that sits somewhere in a room and that responds to emails or ticket requests, we will be just given a task, we would fulfill it and give it back. That would be kind of a function that just provides a model. Now, this isn't very sexy, so to say, right? It might work, but it's modus operandi which makes you work in isolation. So you don't necessarily see the things you implement. You don't really know the entire context. You just get a task and you do it. You do exactly what you've been told. So you want to get out of that and rather become a business contributor, a function that is still a bit reactive, but has a bit of a strategic focus and is already functionally oriented, becomes more of a collaborator. So if you are in that stage, you hear in the organization that the organization uses data science. So it's no longer that many tickets. It's, you become more connected to other functions, but still there is a lot of potential to grow. So what I would encourage everyone to do is to aim to be here in one of these two stages. So either the strategic partner, which is a mostly proactive function that proactively reaches out to product, research, sales, and business, different parts of the organization to look for problems to be solved. A function that can look into the past, learn from the past, but also apply certain things for the future, run some predictions. And a function that is a trusted advisor, where people approach you not because they want to get something done, but because they want a piece of advice from you. So they come to you and they try to solve problems together with you, not just handing out tasks to you. And the crème de la crème is the source of competitive advantage, where you are mostly proactive, you deliver strategic innovation, and you have an enterprise perspective, meaning you're an opinion leader and you're being invited to co-create the goals and the strategies of the entire organization based on the expertise and knowledge that you have. Which might sound bold, but if you're at this stage, you can really help the organization progress in many areas. And so I would encourage everyone to actually think about where is your data function. If you work in data, where are you on these four stages, right? Are you here? Are you there? Or maybe here? And then challenge yourself to think, what can you do to actually move to the next stage? So that's how the setup looks. Now, if you are somewhere here, there's a lot you can do. And now I'd like to take you through a couple of examples which we managed to implement for the cross-functional collaboration. So the first one is the OLX VAS suggester. Now we have to explain what the VAS is. VAS is an acronym for value-added services. And here in that context, we'll be looking at the professional seller. And the VAS is actually something that can help you promote your offers on the listing. So that is the listing, a list of offers. And you can use different tools to either promote your things, bump them up, make sure that they go higher on the whole list. You can put them to the homepage to get more attention, or you can buy a bundle that will do a couple of things at the same time. And for our customers, and this was the biggest problem that we identified together with research, the problem was that using VAS can be very confusing, especially for customers with large inventories. Because if you have just 2 or 3 items and you're selling it because you don't need it at home, you wouldn't care that much how much time it takes to sell, right? You can have patience. But if you're a professional seller and you have hundreds of things to sell, you want to make sure that you get those things out there and you turn that into money pretty quickly. Now, if you have hundreds of things, how do you decide which ones to promote? How do you decide, or how do you figure out which ones are the ones which are most promising, right? How do you allocate your promotion budget? Now, for that, we found a solution to help our customers. We developed a tool that can predict and classify item performance to drive the customer success. What does it mean? We divided all the ads into 4 quadrants. They are not necessarily equally sized. I mean, here the equal size is more for illustrative purposes, but we wanted to identify them on the visibility dimension. So how many times it's being reviewed by people? Is it something that has high relevance, or but maybe lower relevance, so lower the visibility? And then the other 2 dimensions, which are quality and price. So if something is of low quality or too expensive, it will be on that side. And if something is of high quality and the price is right, it would be on this side. So that's how we get those 4 quadrants. So we want to make sure that we find items in this high potential quadrant, which has the high quality or the accurate quality and the right price, and we help them using promotion to move to the sweet spot where they can get more visibility and more attention. And we know that giving more attention to that item will help that item to sell because the price is right and the quality is also fine. We usually wouldn't do that for items from the dark corner, where you have low visibility and quality issues and pricing issues, or the quadrant with high visibility, but again, quality or price issues, because they're promoting that or giving even more attention to these items will not help, because it's either too expensive or the quality doesn't match the price. So we focus here. Now in practice, how does it look? It's a prompt. Hope you can see that. Yes, that's in English. Good. It's a small prompt that appears somewhere in the app, which provides information how much you can gain from buying a promotional option. And what you see here is an example prompt, 10 to 25%. Usually it's more or less like this, like 100 something to 200 something, or even higher, right? Because this is a prototype design. But we inform the user what is the potential gain, what is the performance boost that they can get from applying that particular promotion if they buy it. And this turns out to be pretty accurate. The recent developments allowed us to narrow down the prediction range to be even more accurate with that. So we are becoming better and better at this. And while A/B testing that solution for the first time, we were quite surprised to see how many people actually use it, which again, coming back to the problem that we solve, shows us that it's most probably the right application to the problem. We cannot say that it's the best, because we can still explore many different paths how to apply this and how to make sure that people can use it to their benefit even better. But it shows that we are on the good path to that. So this was the VAST suggester. The other thing I wanted to show is the Autodom radar. And here it's a bit of a different problem, less of a prediction problem, more of a classification problem. And the customer in this case is the real estate agent. Now, if you work in markets like Poland, Ukraine, Romania, Portugal, many times you will experience a situation where real estate agents don't have exclusivity over the offers that they provide. And it ends up in a situation where a single property that needs to be sold is advertised by multiple agents from different agencies, which again ends up in a situation where you have multiple listings, so multiple offers for the same real estate. And this can look more or less like that. So all the 6 images here, they come from the same apartment. It's the same place being advertised by 6 different agencies. So that's the thing. So for real estate agents who don't have exclusivity, it is very important to know who else is advertising for that same thing. Because if you work on a non-exclusive, in a non-exclusive fashion, it's important to be the first one who closes the deal. Because if your offer gets chosen by a potential buyer, if you're able to sell it to that potential buyer, it's you who's going to get the cut, right? Whereas if you miss it, it might be someone else. So what we've done is we built an engine that can actually tell if these are the same offers or not. So for this, we used a ResNet 50 which we trained to actually identify room types, interior types. Is it a balcony, bathroom, bedroom, whatever, to compare the pictures. And we also feeded the XGBoost with all the other attributes of pairs of ads with a comparison metric to make sure we can actually bundle together into pairs ads which are the same, and then using transitive relationships, cluster them together into the same offers. What came out of that is a commercialized product. Unfortunately, everything is in Polish here. It's a product which real estate agents can subscribe to, and it provides them with information about who else is selling or trying to sell the same house or the same apartment. How well is the offer doing? So who's getting more attention, their offer or the competitive offer? And this way they can rate their chances of success and decide if they want to outbid the competition and provide more attention, bring in more attention to themselves through value-added services, or whether they just don't invest behind that and then they go along with it like pretty fully in a fully opportunistic way, whatever happens. But this way you can have the real estate agents, you can give them enough information to make an informed decision, right? They have an insight which allows them to decide if they invest behind this thing or not, which also solves a lot of problems if you work on a lot of offers which are non-exclusive offers. So a couple of key takeaways for you if you think about monetizing data. First of all, use machine learning to reduce uncertainty and help customers make the right decisions. That's the key, because putting ourselves into the customer's shoes, we'll see that they are not that much about data. They're more about selling and being successful, and whenever we can help them do that and become more certain about their inventory, it helps a lot. Now, a quick recipe for data monetization would be the following. Think back from the customer. Who are they and what do they need? Really sit down with them. Even if you have the opportunity to talk to these customers, observe how they do things. Because usually when we do the things we do well, we tend to skip through important details if we explain what we do. But if we allow somebody to observe ourselves, those fine little details become visible. So it's very important to know your customers well. Secondly, define the problem to be solved. And how can we help them, right? That's the question. If they have a problem, try to formulate it in a simple sentence. Next, please look if this is a prediction or a classification problem. If it's either this or that, it's very probable that we can help solve it with machine learning, right? To deliver insights. It won't be always that we need machine learning. Sometimes it can be a simpler solution, but it might be a candidate for that solution. And then once you have this, those first 3 points, only then build the solution. Optimize for high information value and make it simple. So don't start with building things. Start with understanding what is the problem and who needs this problem to be solved, and if it's actually something that fits into the machine learning world. Finally, release the solution to the customers. Measure the impact, and most importantly, listen to feedback, learn and improve. I've seen many times UX research which was not in line with, let's say, this type of guidelines, where something was developed in the hope that it would work, and then customers were actually completely ignoring that thing. And trust me, there's nothing more disappointing than a customer just, not even realizing that something was there. So if we put a bit of work into the preparation and we identify things the right way, we increase the chances of customers adopting the solution, actually making sure that this will become successful. So it's not just boss talk. It's a couple of steps that can save you a lot of time and put you on the right tracks. That's basically what those things do. And yes, if all goes well, I wish that the revenue will be the good fruit of your work, right? And never treat it as the goal itself. Really focus on the customer and the results, and the revenue will come. So that's all, folks.
Yeah, thanks, Tomek. Yeah, there is quite a few questions. So one is from Jorge or George. Sorry, I don't know which way I should pronounce your name. So Jorge was asking about these real estate duplicates. Like, don't you see that they are the same by just looking at them? So why did you need a model?
Imagine you're a real estate agent and you have 50 properties to manage. Right? Would you spend time browsing through all the offers that exist on Autodom, or would you rather spend time with your customers trying to sell? And that's why we created a model, because yes, you're right. You could look through this, but who has time to do that? Right? Real estate agents make money by serving their customers and making sure that they close contracts. They don't make money by looking at things and comparing them. That's how we make money with data science.
But maybe just to understand the size of the problem, like how many listings? Let's take Poznań, right, the city where you live. Like let's take Poznan. In Poznan, how many ads listings are created every day for real estate?
Good question.
Like probably a lot, right? You cannot possibly, like, it's a full-time job of a team of real estate agents to go through.
You wouldn't be able to do that by hand, because total country per month, it goes into the hundreds of thousands of listings. So doing that manually, even for one city, yes, perhaps you could do that, but you would need
hire a ton of interns, right?
Yeah, you need to have like 2 or
interns.
3 interns who just do it like all the time, frequently, every day. I mean, some people try it, but it's not effective, right? It burns your time that you could spend more productively.
Okay, yeah, thank you. And to your point at the end, you showed like a way, like how can we monetize the data? It was like almost an algorithm, right? It's a step-by-step guide. And I was wondering, when you were showing the VAS suggester, you started that talking about this problem by saying we identified, together with research, we identified some problems. So I was wondering, maybe can you walk us through how exactly this collaboration looked like? Maybe not necessarily without going into much details, but in general, like how did it start? How did this research happen? What was the main outcome of this research, and how did you take these insights and actually implement something?
Yes, it starts with relationships. So if you need to have good relationships with your colleagues at work, basically, right? So you don't work in silos. Find the people in other corners of the organization and just make more friends. And what happens then is that when they think about a project, about a research project or a different project, they will usually ask you about if you have any questions to ask. And then most probably you will not have any ideas, but they will share this research with you. And they will invite you to look into things and collaborate. And that's how also this insight came to be, because there was a research run by product.
What is the research in this case?
Sometimes it's a survey that you send out to customers asking particular questions. So that was the thing in this case. There were a couple of questions, I think 5 or 7, about the biggest hurdles that sellers experience on the platform, and they were asked to rank it and also provide a bit more insight on why it is so difficult for certain parts. And that's how this area was identified with 2 others, but this one was really something that we could help solving with machine learning. It fitted the case perfectly, and so we took that and we thought, okay, maybe we can apply this. And then we sat down with product people and we said, hey, there's this insight, right? And then this is an idea. Maybe we can do something together with this, because it could work. So we created a POC, proof of concept. We tested things. Then we tested things with customers. Some things, of course, fail, but it's good to fail if things fail, because that makes you.
By testing with customers, you mean showing them mock-ups, or how did it look?
Not necessarily mock-ups. That by then, I think it was the first test
Already
were done with
POC.
emails. It was already POC was the actual thing on a very small scale, to check what would be the response and how it worked. Not sure if there was UX research. I think
so. You sent
no.
an email and you see how many people actually respond to this email, right? So if 10%, let's say, actually do something and then buy VAS, then it's a good experiment, right?
Yes,
Something
there
like
was
this.
an experiment to see if there would be any reaction, right? So if you see like completely 0, then you would know that something is wrong. But there was an initial reaction which justified the effort to work on the design, to put it into the UI. And then there was another experiment and another experiment. And then for a series of A/B tests, we were looking for the right way to play with that. And that is also how it's going to continue.
Okay.
Iteratively.
Thank you. So go ahead and share my screen. We have a bunch of questions. And the first question is, which database do you store your data in?
That depends. The analytical one is Redshift, and the production one, that's sample we have through Presto, and it's stored directly on S3. So we don't have a database per se.
Okay. Oh, well, so it's multiple databases, right?
Yeah, it's multiple things. It's data is all over the place. That's the. Oh,
So poor analysts, they need to join a lot of things.
yes.
Data scientists too. A question from Adonis. So thank you. Can we have the opposite view? How much bad prediction cost? What prevention methods do you have? Like, I don't know,
Yes.
maybe, I remember you showed this quadrant, right? So here, if we suggest VAS to a bad quadrant, right? So
Yes,
what cost?
thank you for the good words, and it's a very good question, because we had a lot of thoughts about the cost of making a mistake, right? What if you are wrong? So the first stage before releasing that to the customers was cold testing. So if we found a prediction for something, we could apply either a VAS on top of that on our own and see how it performs, or we could check if the predictions that we do actually match the reality. If someone was applying a VAS on their own, we could take the ad and see if this was without VAS, what it would do, and then with the VAS, how much it would get. And by comparing that, we would identify the thresholds of certainty until which we could go. And then actually start working from the top, like with the most certain ads. And then as we were actually making sure that the predictions are more and more accurate, we could lower the threshold and include more and more ads into this. So we made a bit of homework to actually address this point.
Interesting.
So
And in
it also means
case,
the prevention method is that we don't send the prediction if we don't feel certain about that. If it's like from 100 till 600, right? You would see like from 1 time till 6 times. That's a prediction that is too wide, and we wouldn't send a prediction like that. We know that this is then something we have to rework, so we'd rather only focus on the ones that are pretty narrow.
so the short answer is shadow testing, right? So you make a prediction, then you compare with reality. If somebody did activate VAS, and then you say, okay, it works, let's roll it out, and then focus only on the cases where the model is most certain.
Exactly. So
what about, I'm just curious about the other project you showed, the duplicate detection. So what's the cost of mistake there?
It depends if it's a false positive or a false negative. If you have a false positive, usually it's something that you get, you're being notified by the customer that those two things are not the same. And we have a process to figure out if what we got as a request or a notification is actually true. So it's being verified. Because we don't want to have also false information into the system, put into the whole training. And
because agents they have an incentive, right? So that your model doesn't work.
I don't know, but sometimes it's a mistake. Sometimes someone can click the button out of curiosity just to check how it works. Different things can happen. So we want to make sure that there is a filter, a human in the loop to check if what comes back actually makes sense. I don't basically investigate the intentions, right? Just the outcome. Now it's a bit of so if we then have a false negative, we don't show something that is a duplicate, but we missed it. It's a missed opportunity basically for us. But then tuning precision and recall for that model is actually enough to make sure that that's good enough, and that's what we do basically in that case.
Thank you. And actually a related question to this case. What happens if some real estate agents get a photography from different angles?
Oh, the model is quite immune to this. So that's why we also use ResNet and hashing and different methods to make sure that we can actually compare things, even if it's a different angle, even if the colors are a little bit different, it still works.
So if one picture was taken during a sunny day from one angle and another one during a rainy day, or maybe during night from a different angle, you will still be able to get it right.
You would still be able to get it right, because the picture is not the only attribute that we analyze. There are also many other predictors of similarity.
Okay, can you define more precisely how you estimate visibility relevance? Say user searches for Pixel 7, then should Pixel 7 Pro or iPhone 14 be more visible?
Well, that is done using, of course, some embeddings from search and relevance. And we do that within the same entity of the object. So if you look for an iPhone, we would compare iPhones between each other. We would rather not do it between like iPhones and Samsungs, right? So if it's an iPhone, then how does it cut against other iPhones? And how does that pixel cut against other pixels? So we narrow it down to the meaningful entity.
And speaking of embeddings, you mean, for those who don't know what relevance is at OLX, right? So for a listing, there is a way to extract a vector representation of this listing,
Yes.
right? And then you can use this information for each listing to understand how similar they are. I think we actually have a talk about that from Christian.
I think it should be there, but yeah, you're right. I should have explained.
So this one, deep learning recommender system. So check this out. That's a very cool talk from Christian and Ilya, so who show how our recommender system works.
Yes, so we're looking at the vector representations of items, comparing similar entities together.
Okay. So is your concept of visibility customized to each user profile or not? I think it's like a continuation of the previous.
No, it's not. It's not customized to the user's profile. We focus solely on the items. We see how the items perform. It's not related to people's preferences.
It is probably indirectly related, right? So because we use these embeddings.
Yes, indirectly, yes, because people influence the overall statistic of how often an item was viewed, but we don't look into individual people's profiles. That's not relevant here. We look into the total of an item, how often an item was viewed by how many users in total, but it's an aggregate. It's not important who has seen it.
Okay, so that's an interesting one. How do you go from a product for one customer to a larger scale?
I think we generalize it right from the beginning. So we design products with the assumption that it needs to work for a large group of people. So right from the beginning, it's designed in a way to make sure it's general enough. So we don't do things for one customer only, or we rather avoid that, because that could actually trigger something which is focusing on singularity, right? We might focus on singularity and try to crack a single case, and then have something that doesn't work for others. So we usually start from saying, how big is this?
But let's say we start with one market, right? So OLX operates in many markets.
Okay.
So in this case, could be a customer, air quotes, a market, right? In which we think that we can solve this problem. So how can we go from the solution for a particular market to a solution for all markets?
So what happens is we narrow down when we prototype things. We narrow it down to a single category in a single country, even in a single subcategory to simplify the problem a bit. But then we remember about this assumption, and then when scaling, we remove it step by step, increasing the number of categories, and then deploying that also to different countries and markets. So in that context, yes, but that's more less about generalizing, more about scaling, making sure that we can include more and more categories to that.
Okay. Well, I have one more question to you. So one of the slides where you showed was like 4 steps, or
yes, 4 stages of development.
Yeah. Exactly. So let's say I join a company as a data scientist, and I want to be as useful as possible for this company. So I want to work on contributing to the profits of this company, right? And maybe the task I get does not necessarily, like, how can I be useful to the company? How can I contribute to the profits? And how can I select a task that will do this?
Well, basically, if you ask me personally, and that's my personal opinion, it's good to be a bit of a rebel. A curious rebel. A rebel because don't make yourself contained by the silos, right, of the company, or don't put yourself in a box. Get out of that box, and be curious to see what other functions do, right? Where are the problems located? Because that will ultimately inform you about what is the right thing to do. And also be curious about the business metrics or the business goals of the entire organization. Because it's very easy and it's a bit of a trap. You can trap yourself into solving a problem that is a data science problem, that is a fascinating problem, and you can produce a great model that at the end will not be adopted because it's not linked to any particular product strategy or business strategy or whatever, and it lands in a drawer. And that's a pity. That shouldn't happen. So this curiosity helps you to find the right path and then invest your energy into something that will turn into a fruitful model that gets out on production and makes you ultimately happy, right? Because it's also, let's be fair and let's be frank, it's all about having fun, right? To make sure that that we have the satisfaction from what we do.
And you said check what other functions are doing. So what do you mean by other functions? So for me as a data scientist, a function is like a piece of code in Python.
Okay. True. So here I mean, if you look at the organization usually consists of engineering, of software engineering. Then
like this triangle that you showed.
Yeah, then you have business, then you have research, then you might have finance or marketing. So stay close to the functions for which you produce models or code or whatever that is, and then get interested into the goals of that unit, right? If it's a business unit or a product unit, because different organizations work differently. But it's good to know where the whole organization is moving. What is the strategic direction of that organization? To make sure that what you do is aligned with this. Because if you create something that is completely opposite or kind of adjacent, well, if it's really like a brilliant thing, people might get inspired by that and kind of incorporate it, but it's a long way and it takes a lot of talks and energy to get it done. So I would recommend to really get aligned and make sure that what you do is in line with what the company is aiming for.
So I guess from what I understood, we should start with talking to product managers, analysts, researchers, right? So these are people who we have immediately in our this triangle that you showed, right? And then maybe we can go to after that we can go to business people. We can go to I don't know who else we have, like domain people with domain knowledge.
People with domain knowledge, and if you have the opportunity to also talk to business people, please do, because they are usually the customers, the nearest customers, the internal customers. And if you have the opportunity to also talk or observe your kind of external customers, the customers who you serve in the world, it's also worth doing. So visiting a UX research exercise and seeing how customers behave, which language they use, how they use your product, how they understand it, right? How they think, how it works. This is fascinating because then you think that you find out that how you think about the product is completely different from how they see it. And this also helps fine-tune yourself into the mood and deliver something that solves these problems.
And by this research exercise, you mean like user interviews, right? So when a user is shown, we show them a mock-up of a new design or existing app, and we ask them to perform a certain task, and we watch how exactly they do this, right?
Yes, that can be it, because many times prototypes are tested with users. If you know that in your company something like that is conducted, sometimes it's done inside a company, sometimes external agencies are running that. But if you know about it, ask if you can join as an observer and then observe that process. And it will, there's a lot of gold nuggets in there to learn about your products and how customers use it.
When I joined OLX on the first month, actually I got to take part in user research as a subject, or I don't know how to, like, what's the proper term for this? Like, I was tested, like I needed to perform an action. It was actually fun, and then gave me some insight into how the product works. And then, like, I also watched other people do the same, and it was quite insightful.
Yeah.
Okay.
Thanks for bringing it up.
I don't see any other questions. So I don't know, Tomek, do you want to say anything before we finish today?
Well, thank you for inviting, and I hope you'll get a couple of inspirational thoughts from this, and maybe we'll see ourselves in another talk.
Yeah,
somewhere
maybe.
in the future.
Definitely. Okay, thank you, Tomek. Thanks everyone
Thank you
for
very
joining
much.
us today, for asking questions, and yeah, bye everyone.
Thank you,
Bye,
everyone.
Tomek.
Bye.